The following content is meant purely for educational and informational purposes and should not be relied upon as financial, investment, legal, tax, or any other professional advice. This is the Fundamentals podcast, where we demystify crypto and help you navigate this ever-evolving internet-native economy. In this episode, we're joined by Alex, the co-founder and CEO of Matter Labs, the engineering team behind zkSync, a layer 2 blockchain protocol that scales Ethereum with zero-knowledge technology. In this episode with Alex, we discuss what zkSync's core value proposition is and why zero-knowledge proofs are the most viable technology to enable the mainstream adoption of public blockchains. We speak about hyperchains and what the zkSync ecosystem will evolve into on a longer-term horizon. Alex walks us through the current pain points with crypto's UX and how zkSync is tackling these problems. We dive into zkSync Era's economic model, the venture case for a blockchain protocol, and walk through the best metrics to measure the performance of a blockchain. Finally, we wrap up with the current challenges related to zkSync's growth and what the most exciting things happening within the zkSync ecosystem are. Tune in for a great discussion about zkSync and scaling Ethereum's technology and values. Hello, Alex. Welcome to the Fundamentals podcast. It is great to have you on.
Thank you for having me.
Of course, my pleasure. Been looking forward to getting to dive into everything you're doing at Matter Labs with zkSync. But before we dive into the details, could you start by laying out what zkSync's core value proposition is within the blockchain space?
Absolutely. At zkSync, we're solving the scalability problem of blockchains. So it's a mission-driven project, and the mission is to scale blockchains to the extent where we can enable mass adoption, that anyone in the world can access Ethereum and have all the functionality of Ethereum while not giving up the properties that make Ethereum valuable in the first place, including decentralization, censorship-resistant, security, trustlessness, all these things that blockchain is actually designed for. It turns out it's pretty hard to preserve them at scale, and you need specialized technologies for this, and this is what zkSync is all about.
Yeah, that's awesome. I think scalability is one thing, but then preserving the ethos of blockchain, that is extremely important. Now, if we look at zkSync's kind of marketing pitch, it is that zero-knowledge proofs are the most viable technology to enable the mainstream adoption of public blockchains. Can you tell us why that is?
It would require a deeper explanation, but I can try to give you an intuition. What zero-knowledge proofs enable is the proof of computational integrity, and we can do it at arbitrary scale. Now, you have to go back to the original principles of blockchain. We have a thing called don't trust, verify, which is applied in Bitcoin and Ethereum and all the blockchains equally, which suggests that in order to have a truly decentralized network, which is not controlled by a single player or a single authority, you need to build a system where everyone can verify everything that is happening on chain instead of trusting some other people, some validators, some providers. And in order to be able to verify what's happening on chain, you have to perform the computation. And so as you scale, like it can work maybe for a few transactions per second, maybe for 100 transactions per second. But as we scale to the extent of the real world with millions, tens, hundreds, or even billions of people doing lots of transactions, the Internet of Things doing even more transactions with all the trading stuff, with everything, like all things that touch value. If that goes on chain, you will be over flooded with the sheer volume of computation that you have to do, and you will not be able to do it on your single consumer hardware. And so you will be forced to trust some entities to do this computation for you, and then you lose this basic value proposition of don't trust, verify. What zero-knowledge proofs enable, or when we say zero-knowledge proofs, what we actually mean is SNARKs, succinct, non-interactive proof, arguments of knowledge, or proofs of computational integrity. We can do recursive verification of other SNARKs that verify recursively other SNARKs, and we can build sort of a pyramid that is arbitrarily scalable, that can provide the proof of computation of arbitrarily large number of steps. What it means at the end is you can verify all of the world's transactions happening on blockchain for arbitrary long period of time. It can be one block, it can be like number of blocks, one day, a year, since last time you synced with this blockchain. And you can do it in basically 30 milliseconds from your smartphone. You don't depend, the scope of work you need to do to verify the proofs does not really depend on the amount of the transactions or volume of computation that is happening there. That is the magic of zero-knowledge proofs. How it works, I like this is going to be a longer conversation, but let's just assume that mathematically we can prove it with extremely high probability, and this is the property that we use to scale blockchains.
Yeah, that's awesome. A great overview. Let's not dive into the details on this one yet because there's a few other topics I want to dive into over this next hour. But that was great. Now, building on what your core value proposition is, and given the fact that since we saw the first blockchains launched, we've seen a lot of players come out trying to tackle the blockchain scalability trilemma and solve similar issues that you're also working to tackle. So could you speak a bit about what the top optimizations are that you specifically have focused on compared to previously launched blockchains and also other players trying to tackle the same problem?
Sure. So we have to split the other players into two large categories. The one is approaches to scale blockchains without zero knowledge proofs, such as optimistic rollups or maybe side chains, other things. I think they fundamentally will have limitations that they cannot circumvent. They will have to pivot to ZK at some point. And I think, let's not dive into this, but I think there is a broad consensus on this topic with people like Vitalik Buterin and lots of thought leaders in the blockchain space all agree on this issue. ZK rollups, ZK tag is the holy grail of scaling, and this is how eventually Ethereum and all blockchains will scale. Now, if you look at the other players who are doing zero knowledge proofs or ZK rollups, for example, then there are not many of them, and certainly not so many mature ones. So if you look at the basic statistics on the usage, zkSync era launched last year, or sorry, in the beginning of this year, like 10 months ago, is by far the most widely used with the most battle tested technology with most TVL, most transactions, most daily active users. So just this thing puts zkSync apart from everything else. Just more experience, more testimonial, and the ability to process more data is evident from the on-chain usage. But if you want to look into the fundamental differences in the architecture, what we're doing is there are a couple of things. First, we're obviously working to optimize the core of the system, which is the prover, the circuits, the zero knowledge proof system. We recently we unveiled the proof system called Buja, which is one of the fastest, most advanced proof systems in the world, but especially so in combination with the GPU-based prover which we're employing, which has a very minimal hardware requirement footprint. So you only need a maximum of 16 gigabytes of RAM, which is by far the most efficient GPU prover out there that exists. And you really need GPU provers because they are orders of magnitude more efficient than CPUs. And unlike FPGAs or other hardware-assisted proving, they are widely available. We're building decentralized systems. We don't want the prover to be run by a single company or a single provider. It needs to be following the same standards as we are expecting from the mining, decentralized mining aspect, like blockchains with mining, where anyone with a GPU can run their own instance of the prover, and then we kind of collect it from the entire network, right? So GPUs are important. So one aspect is we're optimizing the prover with GPUs and with innovations in the proof system and cryptography itself. This is going to bring us to some fraction of a cent of actual computing costs per transaction, or for an average transaction. Obviously, different types of transactions will require different computational resources, but that means the zero knowledge proof generation overhead is basically negligible. Like you can safely ignore it. Now, the bulk of the costs for any ZK rollup is now coming from data availability. Data availability is basically the need to publish all the data necessary to reconstruct the state of your blockchain. Because if someone controls the state and does not make it public for everyone to be able to observe externally and reconstruct, then you don't have a public permissionless blockchain. Then it's a closed system, which could be shut down by a single entity who controls this data, and there is nothing ordinary users will be able to do. So the way we manage data availability in ZK rollups is we publish it through Ethereum network. We don't use Ethereum storage, but we publish it through the same network that peer-to-peer nodes that all the Ethereum full nodes are doing. which is much cheaper. And this is where the roll-up aspect is coming from. We're kind of rolling up the data together in big batches, and it's much more efficient to just send this batch without doing any computation. All the computation is done on the zero-knowledge proof side and verified by the clients. But this is expensive. And the reason this is expensive is that all ZK rollups tap into the same capacity of bandwidth of Ethereum, which is limited. It's limited by the factors that make Ethereum the most interesting blockchain. Like it's the most decentralized system. The Ethereum parameters of the full nodes are optimized for running on consumer hardware, so you cannot put arbitrary large number of bytes through this network. It needs to be kept at some certain limit. This limit is pretty high, but it's still limited, and there is no way to elastically expand it. So what you want to do in order to be able to provide scalability for the world, to go to this tens, hundreds, thousands of millions of users, you need to be able to A, use data availability very, very efficiently, and B, expand this data availability space maybe with something a bit less secure that the data put through Ethereum, but that provides a relief for the entire network. So maybe for some use cases, you don't need the absolute 100% security from Ethereum. Maybe you don't need to put data on Ethereum at all. You like this data is temporary. Cases like voting or maybe computation for Oracle updates and so on. So in order to be able to do it, you need a special architecture. You need to design your data architecture in a way that enables reusage of slots. We're going to go very technical, but I'm going to dive back out and explain what this means. And expansion of the address space with something cheaper than Ethereum data availability. And this is what we've done with zkSync. And to the best of my knowledge, no other zkAVM approach that exists today on the market has gone down this road. Everyone else is just trying to copy the approach from the optimistic rollups, where the rollups publish the transaction inputs, the data, basically, like what your transaction is, like who is calling what, your signature, and then the full nodes of the rollup have to re-execute all this data. What we're doing, we're publishing transaction outputs. We're only publishing what has changed in the state at the end of the block, which gives us a lot more flexibility. So certain types of transactions will be hundreds, if not thousands of times cheaper with this approach, and you will very soon see this on mainnet, on zkSync era. And in addition, it gives us the extensibility of this address space with technologies such as ZK Porter. This is a class of system which is called Evolution, where users can decide if they want to have their accounts on the ZK rollup, enjoying 100% security from Ethereum, or if they want to use alternative data availability solution, which can range from Celestia to their own servers, to some external providers, to whatever, which is going to be much cheaper with some security trade-offs, but maybe for their use cases, it's going to be sufficient. And with the combination of these two approaches, we can basically scale Ethereum indefinitely. We can scale it without limits. We can expand, just like the internet scales arbitrarily large with an arbitrary number of users and servers added to the network. The same is true for a zkSync network.
Yeah, and like you said, zkSync era launched on mainnet about 9 or 10 months ago, which in itself was a great milestone. So congratulations on that. But I do know that you are definitely not stopping there. You have some pretty ambitious plans on what kind of ecosystem you want to develop. And one part of that is enabling people to build hyperchains, which will kind of seamlessly integrate into the whole ecosystem that you are building. So can you speak about what the ZK stack is and what use case it is intended for?
Sure. So hyperchains are blockchains or ZK rollups built using the technology on which zkSync era is based. We call this technology the ZK stack. It's an open source framework on which anyone can use. It's fully free open source, so you can just download it to develop yourself. You can add components. You can reuse different components. You can configure it in different ways tailored for your needs. You can choose what data availability mode you want to use. Is it rollup, Validium, or Evolution? You can choose what your tokenomics is going to be. Do you want to use Ether as a base token, your own token, or maybe you want to let users pay in any token you want? You can select various sequencing schemes, handling MEVs in different ways, and so on. So like it's like basically arbitrarily customizable for you. And you can launch hyperchains in a way that connect you to the bigger zkSync ecosystem, which gives you access to users and liquidity that are already on zkSync Era and on other hyperchains. So you don't have to bridge assets from, you bridge your funds from zkSync to your hyperchain through some external third-party bridges that are vulnerable to bugs and various security risks if they are custodial, if they are managed by some servers. The bridging within the hyperchain ecosystem is native and seamless. There's basically like extension. You just step into this big thing. You might be wondering, why do we need hyperchains if zkSync Era is already arbitrarily scalable with ZK Porter and with the state extensions? And the answer to this is that there are legit use cases for custom blockchains that are independent from generic purpose blockchains. You can think of social networks, gaming, some financial institutions. You can think of banks that want to launch their own blockchain solutions on Ethereum, deriving full security from Ethereum, validating all the transactions, enforcing it externally so that their partners can trust them to be credibly neutral and to fully enforce the rules that were promised, but still control some aspects of this chain. Maybe introduce a different data availability policies so that they can have transactions private in a very easy way without changing the protocol, without introducing additional layers of privacy solutions. Or it could be a specialized blockchain dedicated to some DeFi application. Maybe you have a high frequency trading exchange where users move funds rarely in and out, but then they do a lot of transactions. And you don't want to share this generic decentralized sequencer because maybe you want very, very low latency, in which case your sequencer has to be centralized. But that could be fine with your users because you still have it's still a ZK rollup. So you cannot change any rules. You cannot do anything wrong with the funds. You cannot even stop users from withdrawing them. But you really need the centralized server to be able to process transactions with 20 milliseconds latency. So the hyperchains based on ZK Stack give you this flexibility and this infinite customizability, if you want.
Got it. Yeah. So is it fair to summarize it in the way that zkSync Era is the generalistic blockchain that any apps can be built on top of, and then the hyperchains are more app-specific chains that seamlessly plug into zkSync Era without having this fragmentation between the generalistic blockchain and app chains in completely different ecosystems?
This is correct. What we see on zkSync Era is basically the full plethora of applications that you would see on Ethereum, ranging from DeFi to NFTs to social applications, to games, to interesting identity solutions, basically the full range.
Yes, that makes a lot of sense. Now, you do emphasize hyperscalability and the importance of security a lot. I think a third pillar that you emphasize quite a bit is improving the crypto UX. Could you speak a little bit about what you see as the main pain points in crypto's user experience at the moment and how zkSync is solving them?
Sure. So for me, the mission of zkSync is to enable mass adoption in the broader sense of this word. So we need to solve scalability, but we also need to solve other infrastructural issues that prevent people from using blockchains broadly. And UX and security are two really, really big and important aspects. Because and they are tightly interconnected. Because most people cannot be trusted with handling their own seed phrases. Right? It's not for everyone. It's by far not for everyone. Especially if the whole experience. You're trying to set up a wallet and you just want to play around with this thing, and on the second screen it tells you, here's the seed phrase that you have to store securely somewhere, and you have to understand that it cannot be shared with everyone. So you probably have your safe in your apartment, which you can put it there, or it's really hard to manage. So we need better approaches to this, and you need also to protect people from making mistakes that are really easy to make, like following a wrong link, doing some like wrong transaction, which can drain your entire wallet. So you want to prevent that. You want to make it very clear that the damage is always limited, and it's very, very clear to you when you sign a transaction what's going to happen, or at least how much is this going to cost you, right? And you want some way to protect the users. So all of that is possible with smart contract accounts, or let's call them smart accounts. Now, the problem on Ethereum is that smart wallets are not the first-class citizen. So we now have account abstraction, EAP for 337 being actively used and actively being adopted on Ethereum mainnet and on other L2s, but it has a number of major limitations. Like it introduces the centralized component. You have to trust some relayer, some third party to manage transactions for you, and you still cannot do certain things. And a lot of applications still don't support mechanisms and APIs that are required to make this wallet's first-class citizen. What we did with zkSync Era is we introduced native account abstraction from day one. As we launched zkSync Era 10 months ago, you could immediately launch the account abstraction based on EAP 4337, but with the full protocol support, where you don't need an external third-party provider to relay your transactions, and you can do whatever you want directly from this account, including things like multi-call, where you can sign one transaction and actually execute a series of them, paying the fees directly from the assets that are stored in your account, paying the fees not only in ETH, but in any token which is fungible, which can be stored in your account, or even making transactions completely feeless for certain types of applications. So this is live. We see adoption of native account abstraction in a few big use cases, especially in Web2 companies entering blockchain world and just bringing their users with them. We see it much less happening on the native Web3 accounts for very unfortunate reasons. A lot of applications want to deploy the smart contracts and the APIs in exactly the same way as they would work on Ethereum. And then the smart wallets are facing a choice. Like, do they introduce some features that cannot work with this older applications, or they want to support it exactly the same way, and it creates some conflict. And so we see it a lot more. We see the native account abstraction being used a lot more by providers that are bringing completely new users to crypto and onboarding them directly into this new paradigm.
Got it. And with zkSync Era being the first EVM-compatible chain to implement the native account abstraction, you mentioned that you have some Web2 companies coming into Web3 that have tapped into this and are utilizing it. But looking at your numbers at the moment, have you seen native account abstraction yet result in any kind of uptick in usage? Has it opened up any bottlenecks?
Honestly, I don't think that account abstraction specifically made a big difference so far. We see probably one of the reasons for this is that the wallets are, like, most wallets don't support it. Most native wallets like MetaMask yet do not support any account abstraction, even Ethereum's EAP 4337. And most users just use those wallets. And so we only see these new applications launching, but they have not yet had a chance to have a significant effect. I think what we see a lot more is the effect from what has contributed to the growth were other protocols and native protocols to zkSync Era that have brought a lot more users. And overall, a lot of people see zkSync as the most future-proof network. So I think that has contributed much more to the growth that we observed so far.
Got it. That's a good clarification. Now, maybe going a bit on a tangent, but why do you think it is that the biggest wallet providers like MetaMask don't yet support account abstraction? Is it so that the crypto native audience is still a big enough market for them to not focus too much on onboarding the masses, or are there too many other bottlenecks for mass adoption that the account abstraction has been a focus point for them?
I think they just had other priorities so far, but I know for a fact that MetaMask and other wallets are working on implementing account abstraction natively in their wallets. So I think we just need a little bit more time for them to crystallize those features and roll them out.
Got it. And that's good, because then you'll be in a great position to capitalize on that as well. Now, I wanted to ask a high-level question about EVM compatibility, because you have built everything from kind of that perspective, that it plugs directly into Ethereum, inherits the good parts of Ethereum, but scales. What are your thoughts on the importance of EVM compatibility in general?
I think that by now Ethereum and EVM has been established as the lingua franca of blockchains. We've seen many attempts to build alternative solutions to Ethereum. None of them has taken off. And there is so much tooling and infrastructure and code already available, and basic services, smart contracts, dApps, wallets that support EVM, that it's going to stick there for a while. I think that we might be the best approach to bring new technologies, new approaches into the space is a way of building hybrid stuff where you support basic EVM, where everything just works like on Ethereum, and then you offer alternative solutions. And then for use cases where it makes sense, people will be building things in other paradigms, like maybe building Rust code for applications or smart contracts that require a lot of expressibility, or reusing some libraries from the Rust ecosystem and so on. So I think that is going to be the way how we will evolve into the future. In a very similar way how JavaScript quickly became the dominant technology for building the web applications in the early days of the internet. And then eventually we've gotten technologies like WASM, where you could run something much more efficient inside the browser, but only as an addition to JavaScript, not as a replacement.
So given kind of the business development focus at zkSync right now, is it so that you are not currently focusing on enabling interoperability for non-EVM compatible chains then?
Oh, we are working on this. We have a strong compiler team working on supporting various different technologies outside of EVM. And yeah, you will see some of these developments pretty soon.
Okay, got it. So your approach is to be as seamlessly compatible as possible with both EVM chains, of course, but then also non-EVM chains in the long run, which does put you in quite an interesting position. And I wanted to ask that, given everything going on within the blockchain space and kind of the fragmentation of different approaches and ecosystems being built, how do you see things playing out in kind of a 5 to 10 year horizon? And where does zkSync fit into that end goal of a crypto native future?
That's a really interesting question. I think that even if we didn't have blockchains, we only had technologies that are completely isolated from each other, technologies and technological stacks possess network effects. Because if something is adopted broadly, then people start working on it, they starting to contribute, building tools, building knowledge base of understanding, people with experience and so on. Right? With blockchains, these network effects are multiplied by the fact that you have your users and liquidity that are always limited, that are always constrained. I mean, you can have your one Ether only on one chain. At every point of time, it can be only on one specific chain, right? And blockchains have different degrees of proximity. It's a lot easier to move the one Ether from one rollup to another through Ethereum than to move it from Ethereum to an external ecosystem, because then you get into the dependencies on external bridges, on some custodial solutions. You involve a lot of risks and costs, which is like way worse than native bridges on Ethereum. But then if you have something like an ecosystem of hyperchains connected through native hyperbridges, then the proximity of those chains is even closer to each other than the proximity to other rollups, right? So those things will shape the network effects to various degrees. And as a result, I think that we'll have a few big blockchain or rollup ecosystems evolving and becoming dominant. And then there's going to be a long tail of different technologies that people try, experiment with, but they're probably not getting so much traction.
Got it. That makes sense. Now, what are the different teams and their roles that are contributing to the core development of zkSync?
Well, we have a long list by now. We have different partners committed to the vision of zkStack and Hyperchains. Obviously, Meta Labs as the first team is still there helping to build zkSync, but there are many more, which I will refer to the new website, which we'll soon put out, and you will have the full list. I don't want to single out some partners at the expense of others. We generally follow the approach of credible neutrality with, like Meta Labs is not credibly neutral as a centralized company, but zkSync as a protocol and as a community and eventually as a DAO, as a network, has to remain credibly neutral. And as long as, like I'm speaking on behalf of zkSync, I want to do my best to remain credibly neutral.
100%. And I will add that list to the show notes for anyone interested in diving in to understand what the developer side of things looks like at zkSync. Now, moving on to your economic model and financials, and focusing on zkSync era here as you're live on mainnet, could you describe its economic model?
Sure. So what you're asking for is like, how can we sustain the development of zkSync core technology for a long period of time? And the answer is quite simple. If you look at the profitability of blockchains in terms of the fees that they generate, you will get quite large numbers. Ethereum is generating a lot of revenue through the fees, and so do other L2s. Like even at a small margin on every single transaction, you will have enough revenue flow to be able to sustain the development of these protocols.
What are the different stakeholders involved who accrue value within the zkSync era system?
It's going to be the network itself with the governance, with the DAO that will govern the network, which we're currently in the process of establishing and giving it over to the community. It will eventually be the community of the guardians of this network. The network has to be owned by the community. It cannot be owned by any single participant, any single company, any single provider. I mean, a blockchain network.
Okay. And as we spoke about hyperchains earlier on, just quickly wanted to ask that how does zkSync benefit economically from new hyperchains being launched and operated within your ecosystem?
There might be different models in those hyperchains, but zkSync in general and all the hyperchains that participate in zkSync benefit from the network effects that co-multiply each other. Like if you have, like you have the Metcalfe's law that the network value is proportional to the square of the number of participants, number of connections. So if you bring 10x more users and liquidity by building 10 different hyperchains, then the utility for every single participant is going to be 100x up. So that alone is a sufficient cause for anyone to participate in the hyperchain ecosystem.
That makes a lot of sense. Now, expanding on Metcalfe's law, in your opinion, what are the best metrics to value or measure a blockchain? Because we're essentially looking at very early stage projects, like you've been live on mainnet for 9 to 10 months. So what KPIs are you internally using to measure success?
That's a great question, and this is still subject to debate what the best KPIs should be. I can give you a couple of examples. So obviously, the total number of transactions, number of daily active users, and monthly active users do play a large role. The TVL is an important indicator that shows the total amount of liquidity available to the chain. You can have metrics like total amount of value that is being transacted on the network that indicates the economic sustainability. You have the fees, total fee flow, total fee revenue of the network, which indicates the real demand. Because if people are willing to pay for these transactions a certain amount of money, then they're clearly getting much more profit from or benefit from these interactions that the amount that they are willing to pay. So this is a very, very strong indicator. So all of them play a role. It's really difficult to prioritize and say that one is more important than the others.
One question, a topic that I speak a lot about with especially investors who have come in from traditional venture capital into crypto is understanding kind of the venture dynamics, especially related to blockchain networks, as they are very different than traditional software businesses. Now, you having raised venture capital, can you describe in kind of layman's terms what the venture case is for zkSync and what the kind of core differences are to a traditional software business?
Sure. The big similarity is that for protocols like zkSync, we have a very clear business model, which we already discussed. The network is generating revenue through the fees. So it's a very clear product market fit, which is a very important thing for investors, that you're actually solving a real problem and people are willing to pay real money for the solution of this problem. And it gives you a very clear path towards profitability and towards some return on your investment. Now, the big difference of blockchain networks to traditional protocol or like traditional products and platforms is that the factor of community is a lot more important. than in other places, because community will eventually own the network. Just by the nature of what these technologies are, they're open source software that are run by individuals that participate in the network. So it necessarily means that you have to distribute also the governance rights to the community in some way. It cannot be kept at a centralized control. It will, like, if you keep the control with a single centralized entity, unlike traditional Web2 platforms like Airbnb, Booking.com, or like Uber, whatever, the community will not accept that in crypto. That's just not going to work. Like, people will not use your network. They will not accept it as a credibly neutral platform to build their businesses, build stuff on it. Because blockchain is all about ownership. There are really interesting examples of people trying to build businesses off the big platforms like Facebook and Twitter in the early days. And then those businesses completely collapsed when the leadership of those organizations and products decided to change the APIs arbitrarily from one day to another, disable them completely, or build their own services that would compete with whatever people were trying to build on these platforms. So you cannot rely on this kind of centralized decision making in order to build something valuable, like even if you're building just normal businesses. But what we're doing with blockchains is we're building things people own. So it makes this credible neutrality of the underlying governance infrastructure even more important. And this is the aspect that you really need to understand as an investor in the crypto space. When you're coming from traditional Web2, this is one aspect you need to learn about and really embrace, really deeply understand in order to be able to be successful in the Web3 world.
That is really well said. Moving to current and upcoming developments within the zkSync ecosystem, what are the biggest challenges related to your growth right now?
Well, we have a number of problems that we're solving as an organization, as a part of this ZK Alliance, different orgs and companies that are contributing towards zkSync. There are technical challenges. They are mostly of engineering nature, and they're just being solved gradually. On the adoption side, I mean, we're still in the bear market time, so like obviously there is not a lot of movement, not a lot of new people coming from non-crypto world into crypto, so the growth is limited, and it's somewhat of a zero-sum game for certain types of applications. But I would not say that those are insurmountable challenges. Like what we're focused on right now is still mostly the product, solving the issue that we know have to be solved, solving certain developer-related issues, some problems with developer experience, which are going to be completely solved within the next 1 month, and solving just bringing the promise of scalability with ZK-powered, with this extensible, reusable data solutions. So those are the main kind of focus areas that we're tackling right now.
Got it. Now, if you're able to highlight kind of any individual developments or trends, what are the most exciting things happening within your ecosystem? So moving on from challenges maybe to more positive developments right now.
So the really interesting things are actually those where the growth is happening, where we bring new users. I can point to the Pudgy Penguin launching on zkSync, bringing millions of users from Walmart to the blockchain ecosystem with NFTs, with onboarding them with like simple QR code scan, giving them the ownership of these NFTs and getting them to start with blockchains. We have some really interesting identity solutions, like we're actually working with a couple of governments in the world, like the solution from Argentina, where citizens of a city will go on chain and will be able to use services directly tied to their cryptographically secured ID account. Let's see. We are experimenting with NFTs also from the community perspective in zkSync. You might have seen the Libertus Omnibus project with experimental NFT minting for people who interacted with different NFT projects, taking really broad adoption in our ecosystem. We see really interesting cooperations going on in the space of payments, and also bringing on traditional enterprises and traditional banking into the world of blockchain and integrating into real-world services. And we, of course, also see the gaming and traditional Web3 crypto-native projects from other areas of Ethereum, and also from alternative L2. So, for example, we have some alternative L2s migrating to Ethereum by using the ZK stack and deploying as hyperchains and becoming part of the Ethereum family, which I find also very exciting. So as you can see, like there are lots of broad solutions all around the space for zkSync.
That is amazing to hear. Such a broad variety of different use cases and applications starting to emerge within your ecosystem. That is a great position to be in, clearly picking up momentum. Now, as a final question to wrap this up, we covered quite a lot of topics during this session, but if we specifically think about your product roadmap, what is next? Is there anything that you can share from your mid to long-term roadmap?
We will share some really exciting news at DevConnect week in Istanbul. So I encourage you to participate if you can in person and just see the news. We'll have some really nice announcements.
Yep, fully understand. Can't share any details yet. A big announcement at DevConnect. Definitely looking forward to seeing what you announce there. Thank you so much, Alex, for taking the time to give us this overview of zkSync and everything going on within your ecosystem. Super fascinating stuff, and I wish you and the team all the best in pushing forward.
Absolutely. It was my pleasure. I really enjoyed the conversation. Thank you for having me.